Imagine waking up one day, checking your GPS, and discovering that the directions it gives you are completely wrong. Sounds like a sci-fi movie, right? Well, it's not, and this could happen sooner than you think. The magnetic North Pole is on the move, and it's changing our world in ways you won't believe. Stay with me because what you're about to hear could reshape how you view the Earth itself. Let's start with this: the magnetic North Pole isn't fixed. Unlike the geographic North Pole, which is stationary, the magnetic North Pole has been wandering for centuries. But here's the kicker: it's now moving faster than ever before. In the last few decades, it's gone from a leisurely stroll to a sprint, covering up to 40 miles a year. Why is it speeding up? And more importantly, what does that mean for you and me? Quick question: if your compass can't find north anymore, does it become a paperweight? Asking for a friend. Let's break it down. The magnetic North Pole isn't just a quirk of nature, it's the backbone of modern navigation. Airplanes, ships, and even Google Maps rely on it to function. Without it, our systems would go haywire. Think about pilots navigating through turbulent skies or submarines stealthily moving underwater. If the magnetic field shifts too much, or worse, collapses temporarily, it's not just an inconvenience. It's a potential disaster. And here's where it gets really scary. The Earth's magnetic field is connected to the molten iron swirling in its core. If the pole moves too far, too fast, it could weaken the field. A weaker magnetic field means less protection from solar radiation. What happens to our power grids, satellites, and even human health? Stick around, because in part 2, we'll unravel how this unseen force shields us, and what could happen if it starts to fail. The magnetic North Pole is moving faster than ever before, and its impact is already creeping into our daily lives. Are we prepared for what's coming? Don't miss part 2, where we uncover the science, and the stakes, of a shifting magnetic world. Have you ever thought about how Earth protects us from the chaos of outer space? Right now, there's a powerful shield surrounding our planet, deflecting deadly solar winds and cosmic radiation. But as the magnetic North Pole continues its race across the globe, this shield, our magnetic field, is weakening. And the consequences? Well, let's just say they're anything but ordinary. Let's start with the sun, our life giver and, paradoxically, a potential destroyer. Every so often, the sun unleashes massive bursts of energy called solar flares. Normally, our magnetic field absorbs or deflects these attacks like a cosmic bodyguard. But here's the problem: as the magnetic North Pole shifts, this field weakens in unpredictable ways. It's like your bodyguard taking a coffee break when you need them most. Think of it like using a flimsy umbrella in a hurricane, except instead of getting drenched, you're dealing with radiation frying your electronics. Back in 1989, a solar storm struck Earth, knocking out power in Quebec for 12 hours. That was just one storm. Now, imagine a storm 10 times stronger hitting a magnetic field that's weakened by a shifting pole. We're talking about global power outages, fried satellites, and GPS systems failing. Picture airplanes unable to navigate, financial systems crashing, and even the internet going dark. Sounds like the plot of a disaster movie, doesn't it? But this is a real and growing risk. And it's not just power grids. The technology we rely on daily, your smartphone, GPS, even weather forecasts, could all go haywire. You know how frustrating it is when your Wi-Fi cuts out for 5 minutes. Multiply that by days or weeks. Suddenly, even basic communication becomes a challenge. In a world so dependent on technology, a magnetic field failure could plunge us into chaos. But it's not all doom and gloom, at least, not at first. As the magnetic field weakens, we'd see brighter and more widespread auroras, the northern and southern lights, dancing across the sky. Beautiful, right? Here's the twist: those dazzling displays come at a cost. The same increased solar activity causing those auroras could also intensify radiation exposure, especially for people in high-altitude areas or frequent flyers. So, should we all start wearing tinfoil hats? Probably not, though they do look stylish. But the question remains, can we do anything about it? To answer that, we need to dig deeper, literally. The magnetic field is powered by the movement of molten iron in Earth's outer core. Scientists call this the geodynamo. When the pole moves, it's because the core's movement is shifting. But here's the kicker, we don't fully understand why it's happening or how to stop it. We're flying blind in one of the most critical areas of Earth science. And yet, some researchers believe the pole's movement could eventually trigger a full magnetic reversal, where north becomes south and vice versa. This has happened before, and we're overdue for another. But what would such a reversal mean for humanity? Could we survive it, or are we racing toward a catastrophe we're not prepared for? In Part 3, we'll explore the ultimate question, what happens if the magnetic North Pole keeps moving, and how can we adapt to a magnetic world in flux? The magnetic North Pole's movement isn't just a story about compasses or auroras. It's a story about the unseen forces shaping our survival. Are we ready to face what's coming? Join us in Part 3 to uncover the full picture. Imagine a world where your compass points south instead of north, where the auroras light up the skies in places they've never been seen before. This isn't the plot of a futuristic novel, it's a possibility we may face as the magnetic North Pole continues its unpredictable journey. But what does this mean for our future? Can we adapt, or are we heading into uncharted territory with no map? Let's address the big question, could the magnetic North Pole's movement trigger a full reversal? History tells us it's not only possible, but inevitable. Earth has experienced magnetic reversals many times before, the last one being about 780,000 years ago. But here's the thing, those reversals didn't happen overnight. They took thousands of years. During that time, the magnetic field weakened, creating periods of instability. And that's where things could get tricky for modern civilization. Let's be real, most of us already get lost with GPS. Imagine trying to navigate when even the satellites are confused. While a full reversal sounds dramatic, the real concern lies in the lead-up. As the magnetic field weakens, it opens the door to more intense solar storms and radiation exposure. Air travelers, especially those flying over the poles, could face higher doses of radiation. And for astronauts? It's like trading your space helmet for a paper bag, dangerous and completely ineffective. We've already seen how vulnerable our power grids and communication systems are to magnetic disruptions. If the magnetic field weakens significantly during a reversal, these problems would escalate. Picture entire regions losing power, satellites going offline, and navigation systems malfunctioning. Life as we know it could come to a standstill. But here's what's fascinating, scientists don't fully understand why the magnetic North Pole is moving faster now than ever before. Is it the beginning of a reversal? Or just another unpredictable chapter in Earth's story? The answers could shape the way we prepare for what's next. So, what can we do? The good news is that humanity isn't helpless. Scientists are developing ways to monitor the magnetic field with increasing precision. Space agencies, like NASA, are launching satellites designed to study the Earth's core and magnetic activity. These tools help us predict shifts and mitigate their effects. But there's a catch, our response time is critical. The faster we detect changes, the better we can protect our technology and infrastructure. Maybe it's time to teach the kids how to read a map, just in case your GPS decides to take a vacation. Governments and industries are also stepping up. Engineers are working on ways to shield power grids from geomagnetic storms, and satellite manufacturers are designing systems that can withstand radiation spikes. But let's not forget the role individuals play. From simple precautions like surge protectors for your home to staying informed during solar activity, small actions can make a big difference. Here's the silver lining, while the magnetic pole shift poses challenges, it also underscores our resilience. Humanity has faced countless natural phenomena and emerged stronger each time. This is no different. With the right preparation, innovation, and collaboration, we can adapt to a world where even the magnetic poles aren't constant. But the real question remains, is this shift a natural part of Earth's evolution, or is there something deeper at play? As science unravels the mysteries of our magnetic world, one thing is certain: the more we understand, the better prepared we'll be for whatever comes next. Will we rise to the challenge? Only time will tell. The magnetic North Pole may be moving, but our ability to adapt and innovate will always be our guiding star. Stay curious, stay prepared, and remember, the world is changing, but so are we.